Let's move on to the pattern matching section for Rust. It's the day 2 part 1. So the match pattern when used for matching values works kind of like switch. The underscore would match any of the else categories that are not covered, and the conditions that are matched are called match guards. So let's start with our sample for the match values. We have an example match values function. Write it something similar to what we had in the example. So if it's simple Q, it'll print quit, and anything else it'll print don't care. Let's first check for this simple bit. Compile and run. Pat match. Since we are sending Q, it's printing quit. Now let's match for the vowels A, I, O, U. And it'll print vowels if sent, any of those characters, so they work like OR, and the ranges can be used as well, and conditions like if and all can be used as well. So let's send it 5 and A, so it matches for vowel, number, and quit. Now with structs, it can be used to destructure the values in it and primarily match it to variables and then use them. So let's create a struct example xy, where the x is for a tuple and y is for a simple integer. An example destruct function will simply create a variable with the values and then we'll match it in different forms, so we can explore variety of ways we can use it to destructure the values within. Here we are matching the Z and 1000, and here by placing 1 we are making sure that only EasyXY struct forms where in the tuple the first element is 1 is matched. So if say we match a struct that had 2, wouldn't match here, and similarly with placing for Y1000 it will match for N and C. Let's copy, make for a separate bit. So say we just wanted value for Y, we don't care for anything else. So doing this, we can just extract the value for Y. Let's fix the copy paste mistake for unreachable typo. There might be some wasteful warnings, so let's call it as well. It's fine. Let's run it again. So as we see, it's able to extract the values within the match and use it there. Similarly, we can destructure enums. Let's write a sample for that as well. We'll start with writing an example enum for EG_opt. So in EG_opt we can have OK and error as our example in the sample, and we'll be passing EG_opt enum from main itself, so we can directly match here. If it's okay, we'll print the number that's part of it. If there's an error, we'll showcase the message that was part of the error, and it'll extract those values by matching it here as it did in destruct. So let's pass 10 for the OK and an error message. I'm using format, we can also use string from. This seems to be working fine as well. Now let's go to the let control flow, so we can have if let, while let kind of fields. So if let EG_opt OKX, we'll be using the enum that we created before just for the sake of ease, and opt it when passed a number will return an EG_opt, where say if n is 0 it will simply return error message, and for other values it will primarily return in EG okay. So by doing let y is equal to if let, the else part can be used, but in else part we can only have return break panic, and in the if block we need to have proper returnable value that can be assigned to y. I forgot the semicolon. Since it's an assignment expression, we need to have a semicolon at the end. Let's call it here as well. As you see, we pass to it's returning okay 200. As we mentioned before, return break panic is needed in the else block. Now sample for while let. It primarily iterates over an iterable and like assigns it to the let var. So here what we'll do is we have a sentence, a phrase primarily here. We'll do a while let over it and reverse it and assign it to another variable. So while let sum x is equal to sentence pop would keep on popping character by character and matching it to x, and then pushing it to the other variable will primarily reverse it and form a new string. As you see, it's working fine in the output. Now on to the exercise part. We need to write a simple recursive evaluator. We're using box. Box is primarily a smart pointer that points to data on heap, allows to store data on heap. And we'll be using result from standard. So let's start with the exercise bit. Let's first define the enum expression. For a mathematical, we'll have a left box expression, an op, and then the right block expression. So like 1 plus 2. So plus would be an op, and then 1 and 2 could be left and right, and can be a simple value as well. And then left and right could also be another expressions like 1 plus 2 plus 5. So 1 plus 2 in itself could be a left block with plus an op and 5 on the right. So now let's create the enum math op, where we'll simply address add, subtract, multiply and divide for now. Now let's create a function eval, or I need to fix that. So the way we'll be returning is a number and a string for the message if needed. Let's make it fn, matching the expression on what is being provided, an op, a value. If it's a value, we can simply give it back as an okay value itself. If it's an op, then we'll need to evaluate it in a recursive format. So if it's an op, it'll have a left, op and right. For the left and right part, we'll need to check if they are an expression in themselves, and that where the recursive part will come in. So let r simple eval, and then it's an okay n, then we'll be returning n to the r, and then we'll be performing the mathematical operation that was the op required. So add, sub, multiply, divide. For divide, let's take care of the divide by 0 as well. So let's pull it out. In simple cases, L by R, unless the R is 0. In that case, I'll simply return the error string, division by 0. This should take care of it. Now let's write a main. Will we write some asserts to check on different expressions? First, let's write an assert for the value itself. We should take care of it. Let's run this and check. Again forgot semicolons at the end of the. Okay, this seems to work. Now let's write some more recursive expressions where we can use them. So first a simple expression with an addition. So we need a left expression value 3 op at and write 7, so it'll again be 10. We'll need a box new for it to be handled. Let's run it, no errors. Let's write an even more complicated expression for this, which has use of the recursiveness. So the left block, let's say we are doing a subtraction. And then for the right block also, let's put in a bit more, another expression in it. Let's divide, and within it again let's put in a value. So as you see, we have value 10, we have 3 plus 7, and then we have a 10 minus 8 multiplied by block of 23 plus 2 divided by 5. Let's copy. Let's run it, no errors. That was it. Thanks.